Hi, hello, namaskar. In this class, I am going to discuss the important concept that is hybridization. This concept is important for the CSIR NET as well as KSET examination. Here, hybridization means, as you know, it is defined as a mixing of atomic orbitals to form the molecular orbital. Means two or more than two atomic orbitals are involved to form the molecular orbitals. Means here n number of atomic orbitals are involved, then n number of molecular orbitals are formed. Means linear combination of atomic orbitals to form the molecular orbital. In the hybridization process, there are two types of bonds are involved, that is sigma bonds and their lone pair of electrons, but pi bond is not involved in the hybridization process. Only the sigma bonds as well as lone pair of electron, sigma plus lone pair of electrons. If it is two sigma bonds are present, then there is a formation of sp hybridization. Three sigma bonds, sp2 hybridization. Four sigma bond, sp3 hybridization. 5 sigma bond, sp3 dehybridization. If there is a presence of 6 sigma bonds, sp3d2 hybridization. If 7 sigma bonds, sp3d3 hybridization. So based on the number of sigma bonds present, these are the hybridizations possible. Here we can see in the hybridization, in the presence of lone pair of electrons, what will be the shape and the geometry of the particular respective compounds. Now in the sp hybridization, if there is no lone pair of electrons, the shape is linear. Its geometry will be the linear geometry, because here bond angle is 180 degree, straight line it is. So here geometry is linear geometry. In the sp2 hybridization, in the absence of lone pair of electrons, its shape is trigonal planar. It's a trigonal shape. So geometry, we can say the geometry of this sp2 hybridization with the absence of lone pair of electron, that is trigonal planar geometry. Here the bond angle is 120 degree. In the sp hybridization, here the bond angle is 180 degree. In the sp2 hybridization, this one bond angle is 120 degree. But in the presence of lone pair of electrons, the bond angle will be vary. So here in the presence of one lone pair of electrons, here this is the one lone pair of electrons, the shape will be like this, bent shaped. So its geometry is either we can say bent geometry or angular geometry or v-shape geometry in the presence of one lone pair of electrons. Here in the sp3 hybridization, there is no lone pair of electrons. Means in the absence of lone pair of electrons, its geometry will be tetrahedral geometry, and its bond angle is 109 degree 28 minutes. Okay, here in the sp hybridization, bond angle is 180 degree. In the absence of lone pair of electrons, I am saying, if there is a presence of lone pair of electrons, the bond angle will be vary. Means in the bond angle variation takes place. So here in the sp hybridization, with the absence of lone pair of electrons, 180 degree bond angle, sp2 120 degree bond angle. In the sp3, in the absence of lone pair of electron, 109 degree 28 minutes is the bond angle. In the presence of one lone pair of electrons in the sp3 hybridization, this is the one lone pair of electrons. So the geometry is trigonal pyramidal. It looks like a pyramid and it is a trigonal shape. So here the geometry is trigonal pyramidal, and in the presence of two lone pair of electrons, so here there is a presence of two lone pair of electrons, so it is a bent shape. The geometry is bent shape, so we can say it is a bent shape geometry. In the sp3 hybridization, with the three lone pair of electrons, in the presence of three lone pair of electrons, here one lone pair, here another one lone pair, here another one lone. So here it is a straight line, so the geometry is a linear geometry in the presence of three lone pair of electrons in the sp3 hybridization. So we go to the next one, hybridization, that is sp3 dehybridization. In the sp3 dehybridization, in the absence of lone pair of electrons, here the shape you can see here, this is the trigonal shape and this is the bipyramidal. So the geometry is trigonal bipyramidal, and its bond angles are 120 degree and the 90 degree. Here two types of bonds are there. inside this trigonal shape, so these three bonds are there. These three bonds called as the equatorial bonds, and these two long bonds are axial bonds. It comes outside, so these both are this one and this one is the axial bonds. So these both the bonds are longer bonds, and these three are the shorter bonds, and these three equatorial bonds are stable to hold the lone pair of electrons. If there is a presence of lone pair of electron in the sp3 hybridization, sp3d hybridization, that lone pair of electrons are associated with the equatorial bonds. Okay, and that is the stable position of this sp3 d hybridization. In the presence of one lone pair of electrons, as I said here, this one lone pair of electrons are associated with this equatorial bonds, that is the shorter bond. So this is the stable structures. So now here, this is, if you see these structures, it's look like a seesaw. So the geometry will be the seesaw geometry or distorted tetrahedral geometry. We can say it is a seesaw or distorted tetrahedral. In the presence of two lone pair of electrons, here one lone pair of electrons associated with these equatorial bonds, another one lone pair of electron with another one equatorial bonds. So it looks like a T. It's look like a T. So the geometry is T-shaped geometry in the presence of two lone pair of electron in the sp3d hybridization. So if there are three lone pair of electrons in that sp3d hybridization, so all these three lone pair of electron are associated with these three equatorial bonds. So the geometry will be linear geometry. Its shape, if you see, it is a straight line. So the geometry is a linear shape geometry in the presence of three lone pair of electrons. In the sp3d hybridization, with the absence of lone pair of electrons, the geometry is octahedral geometry. In the presence of one lone pair of electrons, if here one lone pair of electrons is present, so this is the square structures and this is the pyramidal. So square pyramidal, its geometry is square pyramidal in the presence of one lone pair of electrons. In the presence of two lone pair of electron in the sp3d2 hybridization, this one lone pair of electron, this one lone pair of electron. So its structure is very simple, that is shape is very simple, that is square planar shape, or its geometry is square planar geometry in the presence of two lone pair of electrons. In the last one is the sp3d3 hybridization. In the sp3d3 hybridization, in the absence of lone pair of electron, if you see here, this is the pentagonal structures and these all are the equatorial bonds and these two are the axial bonds. So the shape of this sp3d3 hybridization with the zero lone pair of electron, pentagonal bipyramidal. Its geometry is pentagonal. This is the pentagonal shape and these two pyramids. So pentagonal bipyramidal. Its bond angles are 79 degree and the 90 degree. These are the bond angles of these equatorial bonds and the axial bonds, and their bond angles are different in size, that is 79 degree and the 90 degree. In the presence of one lone pair of electrons, this one is the lone pair of electron. So here the geometry is pentagonal monopyramidal. Only one pyramid is there, axial bonds, are also called as distorted octahedral geometry. Pentagonal monopyramidal or distorted octahedral geometry. In the next class, we will discuss the examples related to this hybridization. Thank you.